二个演讲 ，the second talk, will present by Tomogoto-san. He will talk about the 3D astronomy. Okay, let's welcome Tomo-san.
谢谢大家好，大家早啊！我是 Tomo 在清华大学教电影的老师我先不好意思，我今天讲中文英文，因为我的中文还不好，我的中文还在学习中所以希望明年或者未来我会讲中文，但是今天先拍摄到这。Okay, let's get started. Today, I'm going to introduce our attempts to use 3D printer in my class, in astronomy class at NTHU. Before starting, I want to thank my teaching assistants, Simon and Tiger and Leo. They are my graduate students, and they are the ones who did the hard work for it. And I also appreciate MOE for help in buying a 3D printer. Let's get started. So, today I'm going to start with a very difficult question I'm going to ask you. You guys are professional astronomers, right? But still difficult. Is the Earth flat or round? Do you know? Do you know?
I don't. Tell me.
Really? Seriously?
I'm kidding, of course. Go ahead.
You should fire him. Of course, everybody knows the Earth is flat, right? But Earth is round, right? Oh, I'm the screwed up. But the problem is, so this is in U.S. statistics, only 82% of young people agree with the world is round, the Earth is round. So that means 20% of young people believe the Earth is flat. And then furthermore, there's a society called Flat Earth Society, and then they have members around the world. And there's even a meeting, this is one meeting in a US city, there's an international Flat Earth conference, and 600 people attended here. Do you know this guy?
No.
This Paul Logan, famous YouTuber. He also went to the Flat Earth conference, and most, if you pay attention, what most of these people say is they've been lied to. So, of course, there's education in elementary school and junior high school, right, about science education. That's our education, and they believe it's a lie, most of them. And then, they don't, unless they see it, they don't believe it. But here's the hint. Unless they see it, they don't believe it. Okay? So the problem is here. So we are too small, right, compared to the Earth, the human. So that's why if we see, the Earth is big, right? Okay, so the problem is that we are much smaller than the Earth. So if we stay on the surface of the Earth, then it looks like flat, right? Because of the scale is different. So that's the problem. So they say, oh, this is flat, right? So I know the answer. To solve this question, we make them see it in 3D. We help them to see it in 3D. Then, if they see, they might believe it. Of course, there's Taiwan, and then if we make them see it in 3D, probably they see the Earth is round, right? Okay. The second question, what is this? Orion. Now, does anyone know which star is the most distant one? Famous professor doesn't know.
Obvious.
Yes, exactly. That's the question. So this is the problem of us, astronomy. The most of pictures are 2D, right? There's no information about distance here. But if we make it 3D, then that's clear, right? So this one, Alniram, in the middle here, is by far the most distant one. But this information is not in our 2D picture, so that's a problem. So that's the motivation. That's why we wanted to use 3D printer to help students understand astronomy better. Okay, and then we purchased this 3D printer, and then this is my graduate student scratching his head how to use it. Appreciate his hard work, and then try to use it in a classroom to help students understand. So these are test printing. Oh, he's in the back. He's here. He's trying to print James Webb student, my TAs, and then also Crab Nebula. You can see some 3D structures better, I think, in this way instead of 2D picture. Then this is Earth's magnetosphere. So these are still test printing. Then we use 3D printer in my class at NTH, Introduction to Cosmology. And then the homework or presentation that I gave students is use 3D printer and the printed object for final presentation of the class. And these are what students printed. These are undergrad students taking my class. Some students grouped together to print a galaxy, and then this is our Milky Way galaxy. You agree, right? Well, actually, it was like a pancake, Hondo bean before. But now, they added. Well, we had a discussion, so they added more and more structures, and then finally looked like that. Another group printed solar system. Okay, then another group printed Hubble Space Telescope. Some group printed gravitational waves in 3D. And some other people printed Cassini. And then they use these printed objects in their final presentation, and then to describe the astronomy phenomenon. This is a group about the Milky Way galaxy. Unfortunately, at that time, because of the COVID-19, the presentation was online, but we still used to try to use the 3D models. And then you can see the bubbles and some structures of the Milky Way, right? Spiral arm, halo, bulge. And then they put it up. This bubble was Fermi bubble, and then they discussed about Fermi bubble. And then this, so this is a slide discussing about Fermi bubble. There was a nice work recently by the Zeta X-ray data. They also discussed about it. And then, then after the semester, at the end of the semester, I asked the questionnaire to students. And then most of them replied to the question. And then, so these are comments who took my class, my students who took our class. And to my surprise, it seems most of them enjoyed using 3D printer. So you can see that, this is the first time I created 3D model, or I can feel the sense of achievement. My first time to learn how to draw 3D models. So instead of learning astronomy, it seems they enjoyed learning how to use 3D printer, which is still good, I think. Okay, then, so this is before the semester. How much do you like 3D printing? And the score was something like that. And after the semester, it becomes like this. So you see a little bit of improvement. See, score is getting better after the semester. And then I asked, did you enjoy making the 3D model? And then 85% of students said yes. And then I asked, did you learn new things by making 3D models? And then 100% of students said yes. So I think our project was success. So I thank again my TAs and MOE. And then I stop here. Thank you very much for listening.
Okay, so any question for me?
So how many hours do you take for this class?
How many hours? It's a 3-hour class once a week.
Once a week. And how much do you pay for the 3D printer?
A 3D printer was 2万5千, something like that. 2万5千.
No. It sounds interesting, so I'm thinking.
By the way, if you want our 3D printer, I'm happy, welcome to use it.
Oh, okay.
Yes.
Maybe we can use that in class.
Yes. Please use it because we finished using. So.
Oh, so I can bring it
Yes, no problem, no problem.
Thank you.
Actually, my postdoc will be happy because he's sitting
But
next
I
to
also
his
need
desk.
to learn how to use the 3D printer.
Leo.
Leo.
He's an expert now.
Okay, so Mika.
Yeah, very interesting talk and idea of 3D printers. As a theoretician, I'm thinking, I find it curious that this could be something that could be used even as a science purposes. Thinking to, like, you have a model, but you want to understand it, and I've been trying to make it like 3D models of some of my complicated computer models.
That would be wonderful way, yes.
But then when you are just scrolling it around on a screen, it's kind of but if it was a 3D print, that might be something interesting to as an aid of trying to understand what is.
That's a great idea.
Oh, that's actually quite interesting.
That's a great idea. I actually, when I'm planning this project, I saw some example of theorists printing some the supernova explosion models in 3D, or cosmic large-scale structure models in printing in 3D. Those kind of things I saw, and I suggested some students to try these kind of things, but it was a little bit too difficult for them, so they chose some simpler objects.
Yes.
Thank you for a good suggestion.
Okay, any question for Tomo-san? If no, then thank you.
Thank you very much. I appreciate it, Doctor.